This lecture starts off our Unit 3, and this is getting into bioenergetics. And this is the start of our conversation when we start looking at some of the really cool things in exercise physiology. Now, we're not going to cover everything in this particular unit, but it starts the conversation looking at how the body's using fuel, what resources the body needs, and then it's the seed, or where it's going to eventually go to, is how we start to navigate the nutritional recommendations, understanding how our body uses different substrate like carbohydrate versus fat. And there's a lot of gray area that exists, and a lot of people like to memorize a bunch of stuff about nutrition, but fail to look at the physiological responses or consequences of those recommendations. And so this is the starting point, which helps you understand how the body actually uses fuel and what the body actually needs. So when we get into this conversation of bioenergetics, we connect this to like a vehicle, and most of us drive, and we have to maintain a vehicle, whether it's ours or someone else's we're borrowing, but we all understand the fundamental principle that you need to put fuel in your car in order to make it run. So we have fuel. It also needs motor oil and probably some engine coolant in order to make this thing run efficiently. And so when we put fuel in, we're normally thinking about gasoline, but there's other fuel sources available. We have diesel for diesel trucks, and we have a cool car that runs on electricity. So then the question is, what is our fuel? And when we think of this term of calories or food, food is the right answer. That's our fuel. But we try to measure the amount of food that we have in terms of calories, and that's equivalent of trying to figure out what our miles per gallon is. We know our fuel efficiency based on what we can do, how many miles we can get. But one of the unique things, or one of the things you can't do, is that once you put fuel in the fuel tank, it never becomes engine coolant or motor oil. Even if you're low on engine coolant or low on motor oil, you can't convert one to the other. And vice versa, if you have a surplus of motor oil but you're running out of fuel, there's no switch that you can flip that transfers motor oil over to the fuel. And so when we start looking at our food source, which is food, right? That's kind of messy there. We want to measure this in terms of calories. And calories are the quintessential measuring point for how we have this discussion when it comes to, are you eating too much, eating too little? Calories, just to clarify, are not our energy source. They're not our energy source. It's merely a representation of the potential energy that food may have. Calories is actually a measure of heat. And we start looking at calories, and there's so much attention given to how many calories in a piece of pizza, or how many calories this, and people counting calories. And as I said, calories are a measure of heat, and technically it's the amount of heat that it's required to raise 1 gram of water by 1 degree Celsius. Now, it could be 1 kilogram of water by 1 degree Celsius if you're looking at the large calorie, which is a kilocalorie. But normally when we talk about calories, we're talking about kilocalories. So like 60 calories is usually 6,000 calories, but we just round the numbers down. So when you look at how much potential energy food has, you are introduced to this heat aspect, how much heat's given off. And so when you have a bomb calorie meter, you're basically taking a sample of food and you're putting it in a contained environment, an insulated environment, and you're adding ignition to that food and you're burning it. And you're measuring how much temperature that this water raised by the heat given off from that. And there, in fact, you have your calorie count. So if you wanted to know how many calories an orange had, you'd put an orange in this closed container, you would ignite it, it would burn, and it would raise the temperature of water a certain amount, and that's how you measure how many calories you have. You want to understand a piece of pizza, a broccoli, a steak. So when you start looking at this, and we'll talk more about this in the nutrition lecture, the things you should be eating, things that don't come in a package, like a piece of steak or a piece of broccoli or an apple or a piece of watermelon, whatever you're eating, produce and animal products, agricultural products, you can only assess this once. Once you burn it, once it's consumed, it's done, right? There's no getting that back after you burn it. So you're making best guesses, right? And if things have more water, it's not going to burn. If things have less water, they might burn more based on their mass or their weight. And so calories are a really big estimate in terms of how much potential energy is there. The same is true for looking at how much energy you're burning. You can put a person in a room and measure how much heat's given off, and you can kind of measure the heat exchange that's happening there. So how calories are used is they have this whole thing about energy balance, where you have energy in, coming from carbohydrate, protein, and fat. Those are your macronutrients, or in this case, in this conversation, we're going to refer to them as substrate. And then you have your energy out, which is food digestion, physical activity, and resting metabolism. I do want to point out, though, that when you look at physical activity, how many calories, quote unquote, you burn, that makes up less than a third of your total energy expenditure. The majority, 3/4 almost, or 2/3, is made up by your resting metabolism. So how much muscle tissue you have sitting at rest is more important than how much activity you're actually doing. And there's a small little thermic effect of food that is involved in food digestion. Proteins take a little bit more to process than, say, carbohydrate or fat, but for the most part, it takes about 10% to digest the energy. And the way this is looked at is you have your thermic effect of food, physical activity, basal metabolic rate. If this output is equal to those inputs, you're going to be at what's called a net energy balance, and you'll neither lose weight or gain weight. You'll maintain your weight. If you tend to increase your outputs or decrease your inputs, one way or the other, you tip the scales to the right, you'll be at a negative energy balance and you'll lose weight. And then, of course, the inverse is true. If you increase your food intake and you decrease your activity, you will have a net gain of weight. And this is the way we simply look at the energy balance for maintaining weight. It really just looks at the energy in versus energy out, and this energy balance equation makes two assumptions in this thought process here. It assumes first that all food that is consumed is digested, so everything that burns in that bomb calorie meter is going to eventually end up as accessible energy to the body. And the other assumption is that all food that is digested is utilized as energy. So those are the two assumptions. And if you get those things down, you control your calories, and that you get off your butt and do something, that it's easy to tip those scales. And it's very easy then, if you overeat, to tip the scales the opposite direction. And that should be really easy to go back and forth. And in engineering, this energy balance equation is totally true. You have your known miles per gallon in your vehicle, your fuel efficiency. You have 10 gallons of fuel you put in, and it's a very simple equation to figure out this energy balance. But with this assumption here, all food is consumed as digested, and all food digested is utilized as energy. These are assumptions that are not always true, sometimes more often than not. And the first statement you'll hear all the time is that a calorie is a calorie. And this is a call that all calories are created equal. That doesn't matter really what you're eating. It doesn't matter if it's protein, carbohydrate, or fat, or alcohol. It doesn't matter if you're burning ketones or carbohydrates or fats. That all it comes down to is total calories. That if you eat 500 calories less per day, you will lose 1 pound of body fat per week. That's the simple aspect, energy balance. And the other aspect is just eat less and do more. And it's as simple as what you eat. Just count your calorie intake and make sure you do a little activity, and you should easily be able to tip the scales one way. And if you don't, other way, but back and forth. But the reality is that a calorie is not a calorie. In terms of how much heat it gives off or potential energy, yes, it is a calorie, but it doesn't take in any kind of consideration of the biological or physiological effects that it may have in the body. The other statement, eat less or do more, is a gross oversimplification of human physiology. So the question is what energy source are you burning? And when we start looking at these questions of counting calories and just doing more, these, not that they don't count, that counting calories isn't a worthwhile aspect. It's just low on the priority. These things you see on the screen, when you eat, what you've done 3 hours before, what you're going to do 3 hours later, and most importantly, the hormonal environment you're introducing the food. These things are more important than counting calories. And one of the reasons is that when we look at this fuel, engine, coolant, motor oil, unlike this vehicle that is bound by the law of the energy balance equation, not that it's a law, but by that easily aspect, our bodies can easily take fuel, and if we need it, we can convert it to engine coolant. And if we don't need that, we can convert it to motor oil, and we can convert and change our things around. Unlike this vehicle, when we have a flat tire, we can take some of our fuel and use it for repair. If we get a dent or some chipped paint or any kind of cosmetic aspect, we don't need to bring it into a body shop. The car can do it itself. So the car can't do that, but we as a human body can. The other thing that's not accessible or available to the vehicle is that we can use 3 different fuel sources. You put diesel in a gasoline car, you're going to bring it into the shop. And I don't recall seeing a electric outlet on any of these current gasoline vehicles unless it's a plug-in hybrid. So unlike most machines, we have multiple fuels that we can use. And really this is a moot point, because as we come back to it, the conversation really revolves around this, is that we don't deal with calories. We deal with this molecule right here, which is ATP, adenosine triphosphate. We'll continue the lecture with going into detail of what ATP is and how we start to understand how the body produces that.